Good morning, students. Today we will discuss part third of our chapter units and measurement. And as in the previous class, we had discussed about the physical quantities. What are the physical quantities? What is the meaning of magnitude of the physical quantities? What are the prefixes used before the values of the physical quantities, units of the physical quantities? All these things we had discussed in the previous class, and I had drawn a table in which there is various prefixes mentioned, and I had also dealt with the study of measurement of physical quantities for a very small range to a very large range. Now, today, what are the various points needed for expressing the physical quantities? What things we have to keep in our mind while expressing the physical quantities? So the first point, write it down. While expressing magnitude of a physical quantities of a physical quantity, following points are kept in mind. What are the points which must be kept in mind while expressing a physical quantity? So the first point is decimal is used after first digit using power of 10. Decimal is used after first digit using power of 10. How it is possible? Look at here. For example, if you have to write 3750 meters, then we can express it as 3.750 into 10 to the power 3 meter, or we can express it as 3.750 kilometer. Why it is needed to express as the power of 10? It is used to express, it is generally needed to express the measured value in power of 10, because for various physical quantities which are of very much large range, in that measurement of that type of physical quantity, we only use the range, and for expressing the range we only consider the power of 10. Suppose I am telling about the variation of mass of the earth to the mass of the moon, and let us suppose that if the mass of the earth is 10 to the power 6 kilogram and mass of the earth is 10 to the power 3 kilogram, I am just supposing. So this depicts the not exact value, it only depicts the range is lying in between 10 to the power 6 to 10 to the power 3 to 10 to the power 6D. So for measurement of the bigger quantities, we only use the range, and for the easy knowledge of the range, we express the measured value as the power of 10. Okay? So the range can be expressed as order of magnitude. Order of magnitude. Order of magnitude. It can be expressed as power. It can be expressed as what? Order of magnitude can be expressed as power of 10. Suppose if any quantity is less than equal to the power that is equal to 3.16 and 10 if greater than 3.16. Greater than 3.16. So for example, the speed of light. The speed of light that is equal to 3 into 10 to the power 8 meter per second. So it can be expressed as 10 to the power 8 meter per second. Mass of electron. Mass of electron 9.1 into 10 to the power minus 31 kg. It is approximately, can be written as 10 to the power minus 30, 10 to the power minus 30. Look at here. If the physical quantity, suppose I am written here as 3 into 10 to the power 8 meter per second. So 3 into 10 to the power 8 meter per second, its 3 is less than 3.16. 3 is less than 3.16. Then if 3 is less than 3.16, then it is considered as 1. Then it is considered as 1. Means if the value is less than 3.16, if the value is less than 3.16, then it is considered as 1 and the range can be written as 10 to the power 8 meter per second. Now look at here, mass of electron is 9.1. It is greater than 3.16. It is greater than 3.16. So it can be written as 10. It can be written as 10. Means 9.1 can be considered as 10 and it will become 10 to the power minus 30 kg. So this is about the order of magnitude. So the first thing which we have to keep in the mind that whatever the measured value, it can be expressed as the decimal point just after one digit and expressed as the power of 10, and the order of magnitude, it is used only for defining the range which can be expressed for the order of magnitude, and the order of magnitude can be written as the power of 10. And if the digit or the numeral before the power of 10 is greater than 3.16, then it can be considered as 10, and if it is less than 3.16, if it is less than 3.16, then it is written as 10. I think it is clear to all. Now, the number of significant figures, about the number of significant figures. Second point is number of significant figures in the magnitude of physical quantities. Number of significant figures in the magnitude of number of significant figures in the magnitude of physical quantity can neither be increased nor be decreased. Can neither be increased nor be decreased. The number of significant figures, I will discuss it in the latter section also, but for here I just want to say that the number of significant figures are the numbers which signifies the value of the given number, which signifies or which certains the value of a given measured physical quantity. Example: 3.10 kg cannot be written as 3.1 kg or 3.100. Means you can't increase or decrease the number of significant figures in the measured value. The third one is, these all things are the observations or steps which must be followed while writing or expressing the magnitude of the physical quantities. While making mathematical operation, while making mathematical operations, final result must have proper number of significant figures written by rounding off. Okay, suppose I am multiplying, for example, I am multiplying any two quantities, then the result, suppose I am multiplying 3.1 into 3.00. So after doing this mathematical operation, the significant figures must be greater than whatever the multiplied values. So in the result, we had to maintain only that much of significant figure which had the least value in two multipliers. whatever the least value of the significant figures in both the multipliers, that much number of significant figures can be written in the product so obtained by multiplying these numbers. So it is clear to all, while making mathematical operations, final result must have proper number of significant figures written by rounding off. Okay? After rounding off, we have to maintain, after rounding the result, we have to maintain the same number of significant figures as in case of multipliers. Now, fourth point. Fourth point is nothing. Fourth point is about the doubtful figure. And what are the doubtful figures? The last digit of the magnitude of a physical quantity is called doubtful figure. Doubtful figure. Example: in 3.2 meter, 2 is doubtful figure. What it means to say 2 is the last digit magnitude. It means to say that the measured value can be written as 2 is the doubtful figure, and if 2 is the doubtful figure, means the measured value must lie between two values, 3.1 and 3.2. The true value, if 2 is doubtful, means the true value of the measurement is any value. The true value is any value between 3.1 and 3.3. So the measured result can be written as 3.2 plus minus 0.2. If we are doing the subtraction, we are going to 3.1, and if we are adding 0.1, then we are getting 3.3. Means the actual true value is lying in between these two. So this is the proper way for writing the magnitude. If the 3.2 meter such type of decimal values is given, then last digit is doubtful or uncertain digit, and we have to express the magnitude like that. Now the next point is last digit in the magnitude of physical quantity gives the least count of accuracy. Least count of accuracy. Last digit gives least count of accuracy. The smaller the least count, greater will be the smaller the least count, greater will be the accuracy. Example: 3 kg is less accurate than 3.0. Now here there is a question, okay, why 3 kg is less accurate than 3.0 kg? Because in case of while I am writing the measured value in 3 kg, the least count in this is 1 kg, and in this the least count is 0.1 kg. So as smaller the least count, greater. Here the least count is 0.1 kg, it is smaller than 1 kg, so it is more accurate value as compared to this. So as many least count, as there is more least count, just suppose I am writing 3.234 kg, it is more accurate than 3.0 kg. And the last one, million, billions and trillions cannot be used for writing the magnitude of any physical quantities, because they are absolute, and create confusion. Millions, billions and trillions are not used to write the magnitude, because they are absolute and create confusion. Absolute means what? Absolute means which are not customary, which is not in custom to use. Because why it is not in custom to use? Because the value of billion is 10 to the power 9. 1 billion 10 to the power 9 in USA, and 1 billion is equal to 10 to the power 12 in UK. So this create confusions, since it is absolute and create confusion, so these things cannot be used for the physical quantity, for expressing the physical quantities. Now write one numerical. I will discuss this numerical in tomorrow's class. Question, back the question. The radius of a proton, is 10 to the power minus 9 micron, and radius of the universe is 10 to the power 28 centimeter. Name the physical quantity. The physical quantity physical object whose size is approximately halfway between these two on logarithmic scale. The radius of a proton, radius of proton is given, radius of this is called the order of magnitude. Here it is expressed as the order of magnitude what we had studied before. The radius of universe is 10 to the power 21, 8 centimeter. Now you have to name the physical object whose size is approximately halfway in between these two objects on logarithmic scale. You have to choose the logarithmic scale for this calculation. It is given in the question. Try to do it and we will discuss in the tomorrow's lecture. And now we will discuss the fundamental and derived units in the next lecture. Fundamental and derived units. Fundamental and derived units. Fundamental and derived units we will discuss in the next lecture. So in the next class, in the next lecture, we will discuss, first of all, we will discuss this numerical, and after that, we will discuss fundamental and derived units. That's all for today, students. Thank you.